Hello there guys and welcome to class.
And where did I go wrong? I lost a friend somewhere along.
Teacher Krishna here. We are working on the science subject in class number 3. Let's go over our presentation. Well, if it lets me go. Oh, there you go. Okay, here we have our topic in ending mind. We have topic 1.04, measurement. And here is the ending mind. Determines appropriate measurements for different tasks by explaining why we use metric measurement units in science to be able to determine appropriate graphing strategies for a variety of scenarios. It might seem a little bit long, but don't worry, we are going to be scaffolding it a little bit more later on. And here we have the activities for today. Read topic 1.04 and complete the assessment. That is very important, please. And I'm pretty sure that you're going to have like 15 minutes before the live session. So please, be sure to complete that beforehand. And participate in the measurement practice during the live session. And of course, remember to have the materials. I required the materials last week, so you should have them ready by now. And today is going to be a very interactive class, so I'm sure that you're going to have some fun today. So let's start, and hope you have fun in class today.
Yeah, boy.
Let's jump into our topic, measurement. So, measurement is very crucial for science. And with measurement, we have to be very precise about everything we do. Because small mistakes can cause disasters of millionaire wastes. Such as the one that you can see on the left. That's the explosion of a spaceship. So, if we are not very precise and almost perfect with each one of our measurements, it happens that it can cause a great disaster, just like explosion of a spaceship that you can see right there. I have another example in which a spaceship crashed on the Mars surface because of misconceptions in the use of metric system and the US system. When we talk about measurements, we're going to find several units, just like centimeters, meters. When we talk about specifically distance, if we talk about time, we have seconds, minutes, hours, etc. And depending on the system we use, those units are going to vary. And we're going to learn a little bit more about that later on. But as in one of them we can use kilometers, then in the other one we can use miles. And what happens is that the astronauts or most likely, the machines that were controlled in this specific mission, they were using different systems. So while some of them were talking in kilometers, some of them were talking in miles. And those are gigantic changes that can cause this kind of disasters. So that's why it's very important to take that into consideration. Usually, at an international level, I can tell you that the metric system is mostly used. But we're going to learn some of its differences later on. Alright, so we have an introduction here in which measurement means to quantify the physical characteristics, which are the property that can be described and observed, of something. For example, if we talk about the volume of something, we can talk about the amount of liquid that we can find. For example, the amount of liquid that we can find in those lemons right there. How about the quantity? How many of something we have? So how many lemons do you see in that picture? We have 2. How about the mass? The amount of matter that those lemons contain. Also, we have the temperature of the object. If it is hot, if it is cold, how many degrees Celsius does it have? And here we have some parts of measurement. We need a numerical value and also a unit of measurement. And this is extremely important because later on you are going to be solving some problems. I don't know, probably math in this physics subject. But I have seen a very common problem. Let's say that you want to find the distance or, like the distance of a part of a triangle. So sometimes the students only write down as a result 3. Or 4, for example, but they don't really out the unit or the unit of measurement. They don't say, well, it's 3 centimeters, 4 centimeters, and that's a huge mistake. We always need a numerical value, just like in the first example we have right there. 10 will be our numerical value, and our unit of measurement will be centimeters. How about in the other example? Our numerical value is 1, and the unit of measurement is meter, or the letter L. We have 100 millimeters, we have 1 liter. Please, make sure to include both in your results for mathematical problems. We're going to practice about that later on, but always please have it in mind. I'm sorry, I have a very sore throat right now. I've been talking the whole day, so I need some water. All right. So now we have the metric and the US system. They both are different, just like we studied. And if we are measuring length, in the metric system, we are going to present things in meters, while in the US, we are going to present it in foot. So, let me give you one example. If someone asks you in Guatemala, hey, how tall are you? Well, in my case, I will say that I am 1.8 meters. But if someone asks me in the US, hey, how tall are you? In this case, it will be 6 feet. So, just like you can notice, there is a huge change from 1.8 meters to, 6 feet. All right. And how about weight? In the metric system, we are going to be presenting our results in newtons, while in the US, it's going to be in pounds. We continue, so on and so forth. With mass, we present our results in grams, and in the US, in slot. In speed, we have kilometers per hour, while in the US system, we have miles per hour. In volume, for the metric system, we present it in liters, while in the US, in gallons. Lastly, the temperature for the metric system can be either in Kelvin or in Celsius, while in the US, we are going to have Fahrenheit. This table is crucial for understanding measurement, so you can copy it and add it in your notebook. Oh yes, and by the way, I forgot, please remember to take notes of the most important information that you hear from the video. Okay, so you can take it into account. And keep track of this table, and your life will be way easier. Trust me, especially for the practice we are going to do.
I am the one, the way your time.
Right over here we have another table, and this is going to tell us a little bit more about math connotation. So for example, we have giga, mega, kilo, hecto, deca, deci, centi, milli, micro, and nano. And each one of them is represented by a specific value. So in this game, we're going to have like the names that are going to be matching our numbers right over here. For the giga, it's going to be 1 billion. For mega, it's going to be 1 million, and it is going to be represented just like this. And also we have kilo, which is going to be 1,000. Hecto is going to be 100, and so on and so forth. We can continue. For example, when we say that we have a gigabyte, now you are considering how many kilobytes there are in each one of them. Okay? And so now let's continue. Let's go ahead to the next one. And now we have some more generalities about it. First of all, we need to consider mass and weight. Mass and weight are different. Mass is how much matter an object contains, while weight is the force exerted on a mass by gravity. So, the mass of an object will remain the same no matter where it is located at, but weight is going to change depending on the location. For example, we have this astronaut here, and the mass is 50 kilograms. But when it changes, for example, when it goes to Earth, mass is going to be affected by gravity, therefore the weight is going to be different. So it's going to be, for example, 490 newtons. While we take it to the moon, it can change into 82 newtons. So mass, how much matter there is in an object, while weight, the attraction that gravity has, the attraction pull that it has towards that object. Now we have temperature, the amount of kinetic energy in a substance, or how fast particles move. Probably our eyes cannot see it, right? But all of the particles, all of the atoms that compose a certain substance are constantly moving. When they are cold, they are moving, but just a little bit. And when they are hot, they start moving way more. And the Kelvin scale has the absolute zero. Also, Fahrenheit is commonly used in the US, and Celsius is the more commonly used by the scientific community. Here we have some examples, and we are kind of comparing both temperatures. For example, in this case, we have around 43 degrees Celsius, while in Fahrenheit, you're going to notice that it will be 130 most likely. So it's actually the same temperature, but depending on the scale we use, the numbers are going to change. Let's compare the other thermometer. Right here we have minus 20 degrees Celsius, which is freezing, right? It's pretty cold. But here in Fahrenheit, we're going to have 0 degrees Fahrenheit. That's also something important to consider. How about volume? It is the amount of space defined by boundaries that a substance occupies. Liquids and gases can be measured in liters and milliliters. Solids can be measured through other mathematical processes. And something that we need to take into consideration is that there are several tools or artifacts that can help us out to measure the volume of substances. For example, in this case, we have what we call a meniscus, in which we have this rounded tube in which we can, put the liquids inside and identify its volume. We can also measure length. And it is a one-dimensional measurement of distance between 2 points. Just like I have my ruler right here. There you go. So in my ruler right over here, I can use it to measure, for example, my mouse. So what's my mouse's length? It's around 9 centimeters, okay? And there are some other artifacts that can help us out to measure very precisely some other things. Just like calipers, like EDMIs, and tape measures. Let's continue. Now we have time, and the standard unit to measure time is the second. So let's think about how much time does it take us to, I don't know, probably, let me think, to unlock our cell phone. How much time does it take you? 1 second? 2 seconds? It's a little bit different. Now let's continue. And now please complete the different practice sections that you found in page number 3. Okay? Make sure to go to Agilex, go to page number 3, complete the different practices, and then we can go ahead and continue with our class. We have some other important terms, such as precision and accuracy. Precision is the agreement among different measurement systems about the same thing. So, probably we're interpreting information from different perspectives, like both from the US system or from the metric system. But at the end, they have to be the same. They have to represent exactly the same information, let's say. And accuracy is the closeness of a measurement to the most acceptable value. So, probably we might think that rulers are precise, right? But there are some other tools that can actually measure millimeters. Or actually distances that are smaller than millimeters. So the closest it is to the real value of the object, the better the accuracy we have. Here we have some graphs in which they show the relationship among variables or values. For example, the amount of salt water in our planet is 97.5, while the fresh water levels are of 2.5%. So, now tell me, what else can you find in page number 5? Go ahead, read a little bit, and we'll discuss in class. Oh, those are the activities for the class. Just forget about them, we'll see them later. And that was it for today, guys. Thank you for coming, and I'll see you around. Goodbye.
Bye, have a great time.